Okay, so in this video here, we want to talk about how to rationalize the denominator when we're dealing with imaginary or complex numbers. Now, I already have a video on rationalizing the denominator with real numbers, so if you don't know how to rationalize the denominator, make sure you check out that video first, and I'll go ahead and link that in the description box below. That way you have access to that content. With that being said, let's get right into this video. So my first two problems, you can see that I have an I in the denominator. So we know that I is equal to the square root of -1. So technically, I have an irrational number in my denominator both here and here, okay? Because I comes from the square root of -1, and we know that when we leave square roots in our denominator, we're leaving an irrational number. We don't want to do that, okay? So this would be considered rationalizing the denominator since I have an I there, which again comes from the square root of -1. So it's really simple. If you only have an imaginary number in your denominator, all you have to do is multiply by I. So for example, a complex number is going to be A plus BI, okay? Where I have an imaginary part right here, and then I have a real part right here, which would be considered A. So if you look at this problem here and this problem here, I only have an imaginary part, my BI. So if you only have an imaginary part in your denominator, all you have to do is multiply by I. It's super easy. So let me go ahead and show you how that will work out. Let's get rid of this here. And doing the first one, we're going to multiply both the numerator and denominator by I. So just going ahead and doing that. So we get 5I on our numerator all over 2I squared. Now remember, we know that I is equal to the square root of -1. And so if I square both sides, I know that I squared is going to be equal to -1. So I know that this I squared right here is really a -1. So in other words, I'm doing 2 times -1, I'll get -2. So your final answer is going to be 5I all over -2. Done, okay? And if you want to, you can go ahead and take this negative and redistribute to the numerator if you'd like, but I'm going to leave it there in the denominator, okay? So that one's done. This one here, again, I only have an imaginary number in my denominator, so I'm just going to multiply both the top and the bottom by I. So multiplying by I here and I here, I get -3I all over 4I squared. Now again, we know that I squared is -1, so I'm doing a -1 right here times 4, I get -4. So I'm left with -3I all over -4. And these two negatives here will make a positive since I'm dividing, right? So my final answer is going to be 3I all over 4, okay? And that's done, okay? Let's try a few more problems, this time dealing with complex numbers in the denominator. So here's our next example, and you can see that we not only have an imaginary part right here, but we also have a real part. So unfortunately, when you have a complex number in your denominator, it's not as easy. You can't just multiply by I. Now, if you try to, what happens? Well, if I just multiply by I here and I here, remember, you have to distribute. So I'm taking this I and I'm going to this 2, and I'm also going to this 2I. I'm going to be left with 2I plus 2I squared in my denominator. And yeah, this part right here is going to reduce down to -2, but I still have an imaginary part. So multiplying by I is not going to help you when you have a complex number in your denominator. So to get around that, you have to multiply by the complex conjugate. So let me go ahead and get rid of this stuff here, and I'll show you what that is. It's really simple, okay? The complex conjugate just means if you have a positive 2I, that means you must also have a -2I. Because remember, I comes from the square root of -1. And we know that square roots are always plus or minus. So again, if you have plus 2I, that means a -2I also exists. So the other complex number that's going to exist will be the following. It will be 2 minus 2I. So in other words, 2 minus 2I, and I'm going to multiply that on both the denominator and the numerator, okay? When you multiply by the complex conjugate, that will get rid of the imaginary parts in your denominator, meaning you're getting rid of all of the irrational parts in your denominator, okay? So to do that, we have to do FOIL. First, outside, inside, last. Now here's the cool thing. When you multiply by the complex conjugate, the outside and inside portion of FOIL will cancel out. So for example, if you have FOIL, and I go to multiply this part right here, here's my complex number, I'm going to multiply by its complex conjugate right here. Outside and inside will always cancel out. So all you really have to do is multiply by first and last. Okay, so that's what I'm going to do. So let's get rid of this here. We're going to do first and last. When we do that, we get 2 times 2, I get 4. And then I have to do last, 2i times a negative 2i. That's going to give me negative 4i squared. Okay? And we know that I squared is really negative 1. So I'm doing negative 1 times a negative 4. That's positive 4. So in my denominator, I'm left with 8. Okay? I'm just going to go ahead and underline it so I don't forget. That's my denominator. Now I have to go to my numerator and I have to distribute the 7. So I'm going to go ahead and distribute inside. And when I do that, I get 14 minus 14i. Okay, there's my numerator all over 8. Okay, and that's it. You can leave it like this. Now, technically, you could break this down. You could reduce it. You could do 14 over 8 minus 14i all over 8. And then you could reduce it from here. So, for example, you know that 2 goes into 14 7 times. 2 will go into 8 4 times. Same thing here. You'll be left with 7i all over 4. Okay? So you could write it like this too if you really want to. But either way is fine. Okay? So let's try one more example and then we'll be done. Okay, so here's our last example. Same thing. We have a complex number in our denominator, meaning we're going to multiply by the complex conjugate, which is going to be 3 minus 3i. And remember, when you multiply by the complex conjugate, notice how the real part is not changing. It's only the imaginary part that's going to be changing, okay? But I also have to do that to the numerator, so I'm going to do 3 minus 3i right here. And then we're going to FOIL. So remember, this part right here, when we FOIL, outside and inside will cancel. So I'm going to be left with 3 times 3, which is 9. And then doing last, I get 3i times a negative 3i, I get negative 9i squared. I squared is really negative 1. So I'm doing negative 1 times a negative 9. That's positive 9. 9 plus 9 is 18. So in my denominator, I have 18. Okay? Now, when I go to do the numerator, we also have to do FOIL. But careful here. You have to go through the whole process of FOIL. Outside and inside will not cancel out here. Because if I look at this complex number right here, this right here, 3 minus 3i, is not the complex conjugate of 1 minus 2i. Okay, so it's a little bit different. You actually have to go through all of the steps of FOIL here, okay? So let's go ahead and do that. First, outside, inside, last. I'm going to do 1 times 3, I get 3. Then doing outside, I get negative 3i. Inside will give me negative 6i. And then last will give me positive 6i squared, okay? Now we're going to work on cleaning it up. So I have like terms right here. I get 3 minus 9i. And then I get plus 6i squared. We know that I squared is really negative 1, so I'm left with 3 minus 9i minus 6, okay? And now I have like terms here and here. So combining that, 3 minus 6, I'm going to get negative 3. So I'm left with negative 3 minus 9i all over 18, okay? And that's done. Now, if you want to reduce it, you can break it apart and start reducing. So for example, it's negative 3 all over 18 minus 9i all over 18, okay? So we know that 3 will go into itself 1 time, 3 will go into 18 6 times, so I can write it as negative 1 over 6, and then minus, then looking at the next term, we know that 9 will go into itself 1 time, so I'm left with just I, and 9 will go into 18 2 times. Okay, so we can actually write it like this if you want. Okay, that would be fine as well. So that is how you rationalize the denominator when you have a real or complex number. It's pretty straightforward. Just remember, if you have an imaginary number, all you have to do is multiply by I. But if you have a complex number, you have to multiply by the complex conjugate. So I hope that you found the video helpful. I hope that you gained something from it. If you did, in fact, gain something from this video, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe so you get more math videos in the future, and I'll see you in the next one.